This is Algebra 2, Lesson 4.1, Polynomials, which starts on page 167. We covered polynomials in Algebra 1 pretty extensively to start with in Algebra 1, Lesson 4.2, I believe. There is a video here on TeacherTube that I created for that lesson. That's Algebra 1, Lesson 4.2. In case you are not familiar with the various terminologies that are used in talking about polynomials. Page 167 gives you several definitions that were taught in Algebra 1, and those terms are going to be very valuable to you. If you are struggling in any way with those terms, you're going to want to look at them. And you're going to want to commit them to memory in some form or another, okay? This is page 167. There's all the definitions you're going to need as we do chapter 4. The entire chapter is dedicated to working with polynomials. So, to start with, on page 168, we are going to deal with degrees of polynomials. Degrees of polynomials. This is example 1. Now, the question says, simplify and then arrange the terms in order of decreasing degree of x, then indicate, write the degree of the polynomial. So I'm going to walk you through this. This is example 1, page 168, letter A. X minus 3x squared plus 8 plus x squared minus 2 plus 4x. Okay? So, when you look at it, make sure you've copied it correctly. You know I'm an expert at copying incorrectly, so I want to double check. All right. First thing you're going to want to do is you're going to want to combine like terms. So first I'm going to look at my x squareds. A negative 3 combined with a positive 1 is a negative 2x squared. Okay? So I have taken care of these. The next item I'm going to look at is my x's. A positive x and a positive 4x is a positive 5x. Okay? I'm done with those. The last thing I'm going to look at is my constants. 8 and negative 2, which is a positive 6. Now I cannot combine this any further, so this is simplified. There is nothing more I can do here. Now that being said, we're not done answering the question. First of all, they did say to arrange these in decreasing degree. Now, the degree of this monomial is driven by that exponent floating next to the x. That means this monomial has a degree of 2. This monomial has a degree of 1. You might not recognize it, but x is x to the first power. Okay, but we don't write that. This monomial has a degree of 0. Okay? Now, I've already written them in order of decreasing degree, starting with degree of 2, degree of 1, and this has no degree, there is no variable, so it's a 0. Okay? To indicate what the degree of the entire polynomial is, you choose the largest. And that would be the 2. Okay? So the degree is 2. All right? Letter B, we've got the same thing, only it's bigger, it's badder, it's uglier, but we can do it. B is x cubed y cubed minus 6x y to the 4th plus 2x cubed y minus x cubed, good grief, I'm running out of room here, plus 3x, oops, that should be an x, y4, minus 4x squared y. Wow. Okay. So x cubed y, negative 6x y4, 2x cubed y, negative x cubed y cubed, 3xy to the 4th, and 4xy squared. Looks like I have that all set up. So now we need to first combine like terms. And I am going to start with anything that has an x cubed and try and compare and verify that it has the right y cubed before, or the right y before I try to combine it. I see this is an x cubed, y cubed. That's an x cubed, but it's y to the first. No good. And this is an x cubed, y cubed. So these two items, a positive and a negative, cancel themselves out. Okay, I'm not going to write 0. It's gone. All right? I've got another x cubed. I've got a 2x cubed y. Let's see if there's an x cubed y. Nope. 2x cubed y combined with nothing. There was no other one. Okay? There are no more x cubes, but there is an x squared. X squared y over here. Let's go ahead and move that onto the sentence. X squared y, negative 4x squared y. Okay? That one's gone. Looks like we're left with xy4s. That's easy enough. A negative 6 combined with a positive 3 is a negative 3xy4. Okay? A negative 3xy4. The degrees. This has a degree of 4. X to the third, y to the 1. 3 and 1 is 4. This has a degree of 3. X squared, y1 is 3. And x1, y4 has a degree of 5. Now remember, they told us to write it in decreasing degree of x. So x third is first, x2 is second, and x1 is third. Okay? We have a degree, which is the highest number, 5. Okay? There's your degree. Moving on. When you are asked to add and subtract polynomials, as is indicated in examples 2 and 3, there are a couple of different ways to do it depending upon how your brain works. I'm going to show you what I like, and I'll show you, hopefully something will stick with you. Let's say they write it out as a sentence, as in example 2, where it says 2x squared minus 3x plus 5. It says add this and the other one, x cubed minus 5x squared plus 2x minus 5. Okay, since you are adding these together, you can simply think of it as combining like terms. Like what I did above when I circled and grouped. That's what I like to do. So I am going to look around and I'm going to see the largest degree of x is x cubed. There are no other x cubes, so I'm going to list it on my sum line. Okay, this is where I'm writing my answer. The next degree of x is x squareds. Positive 2x squared, negative 5x squared, so that's a negative 3x squared. That's my next bunch. A negative 3x, positive 2x. Those can be grouped and become a negative 1x. Notice I don't write the coefficient. Not necessary. Negative 5 and a positive 5. Those cancel each other out. There's your answer. Okay? Now, the book on page 168 shows you that you can add them vertically as well. You simply need to make sure that you group your terms with like terms. Okay, it looks like this. Okay, notice there's nothing above the x cubed because the other polynomial does not have a cube in it. You add from top to bottom, and it doesn't matter left to right really because we're not carrying anything. We're not borrowing like you do in standard arithmetic. There's no x cubes to add that to, so you've got x cubed. A negative and a positive. I'm going to put that positive there just for perspective. And it's a negative 3x squared. A negative and a positive, negative x, and that canceled out. So either way, you still come up with the same answer. It just depends on what you're comfortable with. All right? Now, example 3, subtraction. This seems to be the area where I see the most mistakes in Algebra 1. So hopefully you guys will be, this will click with you this year. It says, subtract 2x squared minus 3x plus 5 from x cubed minus 5x squared plus 2x minus 5. Subtract this from this. Okay? That's like saying subtract 10 from 12. Okay, that literally means this is the minuend, this is the subtrahend. Okay? Subtract 10 from 12. We all know that the result is 2, okay, because we removed 10 from 12. In this case, we have to remove x cubed negative 5x plus 2x minus 5 from that, okay? So, I'm sorry, we're going to remove this from that, okay, just like we removed 10 from 12, okay? So, write the minuend first. Then, the item that is being removed goes below the minuend, just like it did here, okay? But line them up underneath their match. So x squared, that's a positive, goes under here. 3x, that's a negative, goes under here. 5, that's a constant, goes under here. Now remember, we're subtracting, so I'm just going to float this little subtraction symbol out in outer space for a minute, because I want to explain to you how I like to do these. You might not, but I'm going to show you how I like to do them. Whenever I think about subtraction, I'm going to go back to 12 minus 10. This one's easy. I think of it in terms of adding the opposite of the number that's being subtracted. Either way, you still get the same answer, okay? For this scenario, adding the opposite is also quite helpful. It allows me to better see the values being combined and make sure that I get the right difference at the end. So add the opposite. Add the opposite. Add the opposite. Okay, however you like to do it is fine. This is just how I like to do it. Now I've converted it into an addition problem, and everything is just going to get combined. A negative 5 combined with a negative 5, you end up with a negative 10. A positive 3 combined with a positive 2, you end up with a positive 5x. A negative 5x squared combined with a negative 2x squared, negative 7x squared. X cubed combined with nothing, x cubed. Okay? So adding the opposite, I feel, is just the easiest way to make these work. I want to do one more with you of that subtraction type, just so that you can feel confident that you know what you're doing here. All right. I am going to do, let's do this. Here's my problem. I'm going to do subtract 3x squared minus 2xy plus 4y squared from, notice I'm using that scenario again, 2x squared plus 3y squared. Now, so that means this is the one on the top, okay? But I'm going to write the one on the bottom first, leaving a space for the one on the top, because I only have two numbers, and I need to make sure that I match them with the correct terms. I'll show you what I mean here. So this is being removed from that. The x squared, I'm going to put right above the x squared. The y squared, I'm going to put right above the y squared. I have nothing above the 2xy. There's my outer space subtraction symbol. Okay? We're going to add the opposite. Add the opposite. Add the opposite. Leaving you with negative y squared, positive 2xy, and negative x squared.